Awesome. Okay, let's begin. Okay, so if you know what CrowdSec is, obviously you know that we have this collective thought process to obviously collaborate between each other. So I'll skip to the next slide. In this webinar, we're going to be learning how the security engine itself, so CrowdSec, the binary, can expose a Syslog endpoint. And then you can use tools such as rsyslog, or if the application itself can send to a Syslog endpoint. So rather than writing to a file, then writing to the Syslog using rsyslog as an example, you could just basically send it straight to the Syslog endpoint, and obviously then it can do the correct processing and everything. So it's just basically another way to get logs from a source into the security engine itself. So we're going to walk through that, and I'm going to provide further context with the drawing that I alluded to earlier. So breaking down what the security engine does. So the first step is we acquire logs. So we mainly do it from files most people use it from. However, we have lots of other different modules, such as like Syslog. So what will be shown in this webinar, how to expose an endpoint. Journal D, Splunk, Elasticsearch, you name it, we pretty much can grab things from there. We then process those incoming log lines from Syslog. As an example, we break it down into the structure, and then we can pass out that information. So when we detect that from the incoming log lines, we can then basically get the behavior, and then we can remediate it. So I'm not going to show you the remediation components within this webinar, because this webinar is solely for just how to expose the Syslog endpoint and multiple ways of doing that. And then once we then detect and remediate, what happens on the back end is that signal or that metadata around the attack is then shared with us. And then we can then basically create a consensus around the IP address that's aggressing. And then if so many people on the network are reporting the same IP address, we can then basically pre-warn or pre-fill everyone else's security engine to say, hey, this IP is bad. You should just block it before it even gets into your network. So that is the crowdsource effect from CrowdSec. Blowing up the security engine, here is the basically per component view of the CrowdSec basically stack. So first and foremost, I like it because in the middle it is the CrowdSec security engine. So this is our bread and butter, as a typical British man would say, is basically how we get the signals from everyone on the network, and how you can basically tap into your own logs to obviously make sure that you're proactive in your security measures. So as I said, we pass logs files or logs in general, Syslog or anything like that. We then detect a bad behavior, what we define. So you can see on the left-hand side, certain things like brute force or anything like that matter. And then there's two things that happen once that's happening, which is basically these two things here. I'm pretty sure I can turn on the laser pointer. Yeah, so we have trigger alerts and then share signals. So once we generate an alert, these are the two things that happen. Obviously, you opt in to share the signals. Once you trigger an alert, it will go to the remediation components to say, hey, can you just automatically deal with this IP address? This is the bad behavior. So it will automatically do that. On the back foot of that, it will also allow you to visualize this report within the CrowdSec console. And that's breaking down on that point there. This is what we already deal with. So we deal with web scans, brute forcing, credential brute forcing, ransomware, credential stuffing, basically anything that is on a behavioral level. More defined is on the application level. So we could be used as like a NIDS so network detection. However, you would have to rely on something else to log that, so we can obviously pass that log files. This is just to give you a broad overview of where CrowdSec fits, because Syslog, in this context of this webinar, can basically log everything and anything, because that's what system logging does. So we fit into the place of where the ingress is coming in. So in my example that I'm going to show you is, I'm going to show you basically a firewall logs, and I'm going to forward them over to the Syslog endpoint. Okay, and now we're going to do demo time. But before demo time, I'm going to show you my good drawing, basically. Okay, so if you can't see it too well, I can zoom in. However, basically, I've created a domain address called photos.ljcybersolutions.uk, which is basically being proxied by Cloudflare. And then I have basically set up an ingress point that is allowing all the stuff to come through, but this ingress point is a full-fledged server. So it's got all the resources that I can throw at it. So it's quite a beefy machine. Now, behind this ingress point, there is what I call a VPC server, but basically think of it as like a Raspberry Pi or some sort of IoT device that doesn't have that much resources for me to just throw at it. And I just point out, I do realize that it's glitching at the top. Livestorm, for some reason, my display driver keeps doing that. I haven't found time to fix it yet. But yeah, so basically I've got a Raspberry Pi behind my ingress, which is basically hosting a photo application. Shout outs to this open source app. I would needed to find an example for this webinar, and I just found this one that was quite easy to set up. And basically it's just like a photo app. I store my pictures of llamas on there. It's just to give you an example of coming in from the ingress and obviously hitting an application that's not on the same server. But yeah, I'll link that in the chat, so if you guys can go over and give it a star or check it out, then it will be great. So looking at but go back to the drawing. So you can see that my firewall that I've set up for, I'll make it a little bit bigger. So my firewall is only allowing Cloudflare to come in to 18443, which is obviously the web server. And it's only allowing 514, which is UDP, and that's Syslog's default port, to come in from the private IP address range. Now, I must stress this enough that Syslog is UDP based and it's a clear text protocol. So any sort of logging you do over this thing can be packet sniffed. So in this example, I'm doing it on a private network. However, if you were doing it, let's say across the internet, because you need to obviously process logs in a different location, it'd be beneficial for you to set up a VPN connection, because then obviously it's not going over the clear text internet. It's obviously being encrypted before it goes across the VPN connection. So yeah, so that's what we're doing. So basically, in short, this VPC server doesn't have enough resources to run CrowdSec because it's just an IoT device. So what I'm going to do is I'm going to set up our Syslog to forward the firewall logs from this server to this central server here, which is where all the processing, because CrowdSec is going to be installed on there. Okay, so let's head over to the terminal. So this is the main box. You can see the IP addresses up in the corner. I know obviously the thing's glitching out, but just to show you that it is configured the way that I wrote it. So looking at my logs, you can see that I only accept TCP connections from the set of Cloudflare 4. I only accept UDP connection to the Syslog endpoint from my private address range. And then anything that doesn't match, which it hits to the very end, will be logged. So if I cat my var log kern.log, you'll see that I've got all these people knocking on my door because that's where the IP tables is logging to. On the second server, this is where my IoT device is. It's not really an IoT device. It's basically a second server that's running in the cloud. But for this example, I'm just showing you how you would use the Syslog endpoint because that's the context of the webinar. So I've got limited resources on here. I can't install CrowdSec. So I can see that if I look at the same log file, I'm still getting a lot of people hit this device and they're all being blocked. So I want there to be some sort of protection for this device, and I want to forward these logs across to the Syslog endpoint. So the first thing that I need to do, because there's no CrowdSec on here at all, is I need to install CrowdSec. So this is quite simple. You head over to docs.crowdsec.net, go on to install, and you can basically find the kill that will basically download the repositories and scaffold CrowdSec, the repositories. It will take just a moment. Once that's done, we'll just do, because I'm on Debian, apt install CrowdSec, and give that a -y just so it doesn't ask for confirmation. Okay, so you can see on here, this is what the color text that you're seeing, if you've never installed CrowdSec before, is what we call auto acquisition mode. So it basically scans for services that are running on the device. So you can see that I've got nginx running because that's my proxy that comes in. SSH because it's a Linux server, everything runs SSH, and it basically will configure CrowdSec to monitor those log files. So if I do anything like CLI metrics, let's just give me a second. That's where I was in a second. So if I go back to my photo app and I refresh the screen a couple of times and then come back to the other screen and do CLI metrics. Okay. Let's go check the acquisition. Acquis.yaml. Okay, so it has got the log file and the error log file. X. Yeah. Okay. That's odd. Let me just double check the CrowdSec log for any errors. No errors whatsoever. Okay. So because that's already scaffolded, it's already monitoring that stuff, I'm going to now set up this syslog endpoint. So if I head over to docs.crowdsec.net, there's a whole dedicated section on the left-hand side to data sources. So these are the current data sources that we support, and one of them is exposing the syslog endpoint. I'm just going to copy this example that's in the middle, and I think pretty much the configuration keys pretty much talk for themselves of what they exactly do. I'm then going to create a directory called acquisition.d. So in new versions of CrowdSec, you can create this acquisition.d directory, and any configuration files in there will be included with the acquisition.yaml. It's just so we don't get a massive acquisition.yaml file and we can break them down into smaller components. So I'm just going to double check that I've got Vim installed. I do indeed. And then I'm going to Vim etc CrowdSec. Did I create it in the right place? No, I did not. I did CrowdDeck. Okay. Rule number 1, make sure you spell it correctly. I'm going to go to Acquis.d and I'm going to create Syslog.yaml. And then I'm just going to paste the example that I copied from the website. However, for me, I'm okay with using the default port, which defined in the documentation says UDP port, and it defaults to 514. And I'm okay with exposing that on my private network. So I'm going to comment out this. However, I don't want the syslog to bind to the loopback interface because I want another server in the same virtual LAN to connect and speak to this machine. So I am just going to head over to DigitalOcean, which is where I'm hosting the server. Sorry for the white screen if it's going to blind you. And I'm going to head over to the 206 one. And I've got a private IP up here. So this is my private IP address that's in my virtual LAN. I'm going to copy that, head back to the configuration, and I'm just going to paste the listen address into the section where it was based on loopback. So when I save this configuration, and then go into restart CrowdSec, give that a second. And now if I do sudo ss lnup, so that's listen, list out the ports that are listening and they are on the UDP protocol, you'll see now that I have CrowdSec that's exposing UDP port 514 on my private IP address range. So it's not exposing that port to the internet. So if anyone sends me any syslog stuff, I'm not going to process it because I'm only solely listening on the private IP port. Okay, so that's all the configuration that we need to do on the CrowdSec, because all we need to do is expose the port and do it. However, I just remembered, since that I want to forward my IP tables, like firewall rules, we're going to have to install the parsers, because it's not like you're in a multi-server setup and the parsers are local to the security engines. This security engine is receiving logs and it will process them themselves. So I'm just going to install crowdsecurity /IP tables. Okay. And then once that's done, we're just going to restart CrowdSec again. So now it's got the rules that it needs to pass the logs from my remote server, and it's now exposing that UDP port across my private LAN. So now I'm going to head over to my other server, and this is where I'm going to define inside our syslog that any logs, the kernel logs from IP tables, will be automatically forwarded to that machine. So the way that we do that is if we, let's double check that I've got my text editor Vim installed. We do indeed. So if we vim etc and then rsyslog.conf, this is the default Debian configuration. For Debian 11, let's put it that way. Just FYI, Debian 12 has completely removed rsyslog out of the box. So for Debian 11, this will still apply, and anyone that's pretty much using rsyslog can do this. So at the moment, anything that's coming from the kernel is being dropped straight into this varlog kern.log. However, I don't want to send all kernel logs to CrowdSec because it's pointless. I only want to send the IP tables rules there. So I just need to take a sip of my coffee. Has anyone got any questions? Remember, you can use the questions in the bottom right. Okay, so I don't want to send all my kernel logs there because CrowdSec only cares about IP tables rules because that's what I've defined that it should care about. So I am gonna just grab a configuration that I tested earlier because obviously I want to make sure that it works and I don't get struck by the demo gods. So I can add this filter into the line, which if I zoom in just to make sure you can see it, I am filtering the message and seeing if it contains IP tables in brackets, because if you remember my example, that's what I prefixed the log to do. So it wraps it in IP tables. And it's going to use the forward syntax. So when you see an at and then an IP address, and then obviously the port 514, if you see one at, that is UDP. If you see two ats, that's TCP in our Syslog format. So obviously I don't want that. I only want UDP format. So that is one at. And then you have the private IP address of my other server. And the UDP port that I'm listening on is 514. So if I save this and if I tail out my var log kern.log, you'll see that my IP tables rules has the IP tables in brackets. That's obviously what I'm filtering on to send those across to CrowdSec that's listening on that other server. To make sure that configuration takes effect, I'm going to have to do systemctl restart our syslog. And because it can be funny sometimes, I would recommend that you do a status on our syslog. And I can't spell systemctl apparently. So if you do systemctl and you see that there is no red text here, then that's good. If you see red text, then you either have a firewall issue or you entered in the configuration wrong. For me earlier, I didn't realize the difference between two ats and one at. That's why I defined it to you now, because I didn't realize that two ats means TCP and one at means UDP. Okay, so we've now configured CrowdSec to, well, we've now configured our server to filter down the IP tables rules. And then whenever it hits one of them, it's going to forward it across to our other server that's listening here. So if I do CSCLI metrics now, you'll see that I've now got a bucket for IP table scans multiports. And you can see now that I've got Syslog and it's telling me where the IP address is from and how many lines it's sent across. Obviously, because I've only just enacted the configuration, it has just scanned the one line that's been sent so far across there, and it managed to pass it because if we look at the IP tables logs, it says that there's 13 variables been passed out of it, and that the current count for the bucket is 1. So that is simply how that works. Is that we're just taking our syslog is basically sending a UDP packet across to CrowdSec saying, hey, this is the IP tables logline. CrowdSec is then passing it out, realizing that it's for IP tables, and it's then grabbing all the variables that it needs and creating the buckets as necessary. And then if we look at the server, there is no obviously overhead on this original server because it's automatically doing all the stuff across. So yeah, just pre-warning, if anyone does any like port scans or anything like that, obviously you might get trigger a rule against it, but you can see that it's still chopping and chugging, it's still going away and obviously doing the stuff there. Has anyone got any questions? I know that it's not really like a wow factor because it's kind of like we're exposing the port and then our syslog is just sending across the packet to say, hey, this is the IP tables rule. But it's quite interesting because most people will just install CrowdSec in multiple locations, where sometimes if you've got like a device which is restricted in resources, you can just install, well, our syslog comes on many distributions, but you can just use our syslog to forward that across to CrowdSec as an endpoint. The one thing I do note is that CrowdSec syslog endpoint does not log anywhere because that's not what it's supposed to do. It just takes in the packet and then passes out the variables and then does the bucket stuff. So if you have let's say, because you can do it with nginx, and that was going to be my next example. Let's say if you're running into an issue with nginx, and you need to actually look physically at the log lines. If you set it up to just forward to a syslog endpoint, you won't have any of that log lines data to look at, because it's just sent it to CrowdSec, and CrowdSec's obviously just consumed it, and it won't pass out the lines everywhere. So the next example of which I'm going to show you is the Syslog, which is Podman pods doing the doing the Syslog across the container network. But I was pre-warning you that if you're debugging a problem with the web server, it can be quite difficult to get the information out if you're going to do it in this way.
Hello, this is the President Lawrence. I cut the webinar a little bit shorter, as the next 5 minutes was just me rambling on about showing you the Podman example or not. And in the end, I decided that I will make it a part of the YouTube video. So moving forward, this will be that section. Now to start, I will be using Podman version 4.6.1. Your version must be at least a supported version that has defining volumes within pods. I did try to use Debian 11 before reverting back to Arch Linux, and they only had version 3.6, which did not have this as a supported version. So before moving ahead with creating the pod, just ensure that the Podman pod create command, if you just give it the help flag, will allow you to define volumes within the pod. Now I am going to paste in the pod create command. As you can see, we define 2 volumes, one for openresty and then one for CrowdSec. We also define a port mapping from the host to the pod containers, and this will be port 7070 on the host, and it will go to port 80 within the pod, which is where openresty listens by default. However, before we can run this pod create command, we must first create the volume. So I will just cancel this command and run podman volume create. And the first volume we're going to create is the crowdsec_etc. Upon hitting enter, you'll see that the name of the volume that you've created will be set back to you. This is just to confirm that this is the name of the volume that was created. So we're just going to replicate that same command, and we're going to run it for the openresty volume as well. Once we have defined both volumes, we can then head back over to the podman pod create command and just run it as is. Do note, when you do run this, it will give you back a random letters and numbers. This is the unique identifier for the pod. So what I like to do, just to make sure that I don't need to remember this unique identifier, is we will set it to a environment variable called $pod. So you just do export pod equals and then assign it to that. We can ensure that the pod variable is set correctly by running echo $pod. Now, since we've got the pod created and the volumes created, we can now start assigning containers to the pod. The first container that we're going to do is the CrowdSec container. So we start this by doing podman run, give it the -d flag, which is detach, and then we assign it the pod by doing --pod, and then we will use the variable that we set earlier, the $pod variable. Since this CrowdSec container will be part of the same pod as an openresty container, we can define the collections variable using the -e, which is environment, and we do collections equals, and then we can pass crowdsecurity/nginx. The reason that we do this is that on container startup, it will check this collections variable and it will automatically install the nginx collection for us. We do define another environment variable called disable parsers, and inside this I define crowdsecurity/whitelists. However, I only define this because this is a virtual machine within my computer, and just for test purposes, I disabled this parser. However, in a real production environment, you may not want to do this. Upon clicking enter, I do realize that I made an error, so I have to go back and fix this because I didn't set a default registry. So to fix this in my version, I had to do docker:// to define that it needs to go to the Docker registry to find this container. Once the container is deployed, we will just need to ensure that everything's running smoothly. So I just do the podman logs -l command, So the L in the logs command just means bring back the latest container that I deployed. And as you can see there, it has automatically installed the nginx collection, and it is a healthy service. So within these next few snippets, I will just show you that I inspect the container, and you can see that it has the volume mounts that I defined within the pod, where the volume is mounted to the host. So to do this, you can easily just do podman volume inspect and then find the CrowdSec directory. And then I just pipe it to a command like JQ, just so I can get like a pretty format. So as you can see, that the volume is mounted to varlib containers, and that's where I would find CrowdSec's configuration files. Heading over to the mount point, this is the CrowdSec directory. So within here, we can vim the Acquis.yaml file, which stands for acquisition. So since on this deployment, I am not reading any log files, I'm going to remove all the current entries, and we are going to head over to the CrowdSec documentation. And as you can see, it has an example configuration for the Syslog server. We are then going to copy and paste this into our acquisition file. However, for myself, I don't need to listen on a different port. And if no port is defined, it will bind to UDP port 514, which is the default for Syslog. Before we restart the CrowdSec container, we should add the openresty bouncer, and we can do that simply by running Podman exec with the container ID, and then just do cscli bouncers add, and then in my case, I called it myresty. Make sure you hold on to this API key as you will need it later. Now with the power of editing, I'm going to show you how to fix an issue before you hit it. So as you can see, my shell doesn't look exactly the same as where it was before. So we're going to head into the CrowdSec directory, and we're going to create a directory called bouncers. And within the bouncers directory, we are going to create a file called crowdsec-openresty-bouncer.conf. The reason that we have to do this is because since we're overriding the default SE directory, the container cannot mount its default configuration file, so we must manually create this for now. I will leave a link in the description that will go straight to this configuration file that you need to paste. Once you've pasted the configuration file, you can just close the file for now. Now we can go back to where we were before, and this is where we're going to run the openresty container. This is where you would need your previous API key that you should have saved. If not, just go back and just rerun the same command. I will paste in the Podman run command, and as you can see from the environment variables, this is where we would define the API URL and the API key, so make sure that you define the key that you have. We can define the API URL as 127.0.0.1 port 8080. As they are in the same pod, they will use the same network namespace so they can talk to each other over the loopback interface. And also, line you should be able to see --pod. We will make sure that obviously that we assign it to the same $pod instance as the CrowdSec container. Again, I made the same mistake, so just make sure that you prepend the image with $://. Once the container is up and running, we can ensure that it's healthy by running podman logs-al again. And if you see initialization done, that means that the bouncer has been able to read the configuration file and it is all working correctly. If, however, you do receive any error messages such as cannot find configuration file, then please revert back over the last 2 minutes, and that will inform you how to rectify the issue. Next, we need to configure the openresty or /nginx, send its logs over to the Syslog server. So we will head into the openresty mounted volume, and then we will head into the nginx directory, and within there's a conf directory. Heading into there, you should be able to see a bunch of configuration files, and the one in particular that we need to edit is the nginx.conf file. Heading down the configuration file, you will be able to see a commented out section called access log. So we will uncomment this line and make an amendment so it knows that it needs to send logs over to the Syslog server. And the way that we informed nginx to do this is that we can change the middle section where the file normally goes, that we can say syslog semicolon server equals, and then the loopback interface, which is 127.0.0.1. The reason that we don't need to define a port is by default, nginx will just presume that it's a syslog port of 514 UDP. Before you quit and save, just note that you also need to uncomment the top 3 lines just above where we define the syslog server. That's because we want to use the main format and it's not defined by default. Once you have saved and quit, you can then run the podman restart command with the -l flag, and this will just restart the openresty container since that was the last container that we ran. Before we test the Syslog acquisition, we should restart the CrowdSec container since that we haven't restarted it since we've done the changes to the acquisition itself. Now we can test this by running curl to the local container, and that will obviously return the openresty default page. Then execing into the CrowdSec container, if we run the metrics, we can see that we get the Syslog acquisition. And finally, I would like to just say a personal thank you for spending the time on this webinar. If you tuned in live or if you tuned in on the YouTube video, make sure you hit that like and subscribe button, and I'll see you in the next video.